Hello everyone, my name is Namrata Patari and my topic name is Analyzer, Detectors and User Computers in Mass Spectroscopy. Here first one is what is a mass spectroscopy? Mass spectroscopy is a powerful analytical technique used to quantify known materials, to identify unknown compounds within a sample and to elucidate the structure and chemical properties of different molecules. In mass spectroscopy, having three main components. First one is the ionization technique, second one is the mass analyzer, and third one is the mass detectors. First one is the mass analyzer. In mass analyzers, is also called as ion separator. Mass analyzer is the heart of the mass spectrometer that takes ionized masses and separate them based on charge to mass ratio. Mass analyzer must possess the following characteristics. It should have a high resolution. It must have high rate of transmission of ions. Different types of mass analyzers. First one quadrupole mass analyzer. Second time to flight analyzer. Third one magnetic sector mass analyzer. Fourth one single focusing, double focusing, quadrupole ion trap mass analyzer, and last one ion cyclotron resonance. Here first one discuss about quadrupole mass analyzer. In quadrupole mass analyzer, it consists of four voltage carrying rods. The ions are passed from one end to another end. During this apply, the radio frequency and voltage complex oscillation will take place. Here the single positive charge ion shows the stable oscillation and the remaining shows unstable oscillation. Mass scanning is carried out by varying each of the RF, RF means refract, RF and voltage frequencies ratio, keeping their ratio constant. Quadruple ion storage. It stores the unsorted ion temporarily. They release to the detector by scanning the electric field. Advantages of quadruple mass analyzer. It gives classical mass spectra having good responsibility, produce relatively small and low cost system. Having a limitations, it produces limited resolution, peak heights variable as a function of mass, not well suited for pulse ionization method. Applications in GCMS and LCMS systems, triple quadruple MS system, bimolecular detection. Second one is time of flight mass analyzers. In this analyzers, the sorting of ions is done in absence of magnetic field. The ions produced are acquiring different velocities depending on their masses. In time of flight mass analyzer, the particles reach the detector in the order of the increasing order of their masses. Here, electron multiplier detector is used. The resolution power of this is 500 to 600. The basic principle of time of flight mass spectrometer or mass analyzers. Advantages of this mass analyzer. It produces theoretically unlimited mass range, moderate to high resolution power, moderate cost, relatively high duty cycle. Instrument is not scanning. Third one, magnetic sector mass analyzer or single focusing magnetic mass analyzer. A single focusing magnetic mass analyzer, it has horse shape class 2 which is evacuated consists of simple inlet electron bombarding source, accelerating plate on one end and collector slit at other end. At curvature of tube there is provision to apply electric magnetic field. Sample in the form vapor is allowed through inlet and bombarded with electron beam at 17 electron hole. It knocks off one electron from every molecule, then they become positive charge ion. As this molecule become positive charge, they are accelerated by accelerating rates and travel a straight path. By application of electric or magnetic field, they travel in curved path and molecular ions are separated according to their masses and collected. Different fragments fall on detector, then mass spectrum is recorded. Fourth one is double focusing magnetic mass analyzer. In double focusing mass analyzers, it is used to differentiate the small mass differences of the fragments. This provides the high resolutions. To achieve better focusing, energy has to be reduced before ions are allowed to enter the magnetic field, and increased resolving power can be obtained through mass analysis in series. In double focusing mass analysis, beam is first passes radial electrostatic field. Advantages of double focusing mass analyzer: it has the classical mass spectra. It produces very high responsibility, having high resolution power, high sensitivity, and high dynamic range. Limitations of double focusing mass analyzer: it will not well suited for pulse ionization methods, example MALDI. Usually large and higher cost than other mass analyzers, which means double focusing and mass analyzer which have a higher cost than other other analyzers. Application of mass analyzer: double focusing mass analyzer, the all organic mass spectroscopy analysis method. It produces all organic MS analysis method. Accurate mass measurement produces isotope ratio measurement. Fifth one is quadruple ion trap mass analyzers. In this mass analyzer, there are two principles. It produces three-dimensional quadruple ion traps. This dynamic means traps. And ion cyclotron resonance mass spectroscopy. Both operate by storing ions by using DC and RF electric fields. Here is the block diagram of quadruple ion trap analyzers. Sixth one is ion cyclotron resonance. In ion cyclotron resonance mass analyzers, the ions in a magnetic field move in circular orbits characteristic of their m by z values. If energy is provided at a frequency equal to their precession frequency and in a direction perpendicular to their plane of precession. In ion cyclotron resonance analyzers, ions will absorb the energy, enabling them to be detected. Here is the diagram of ion cyclotron resonance. Advantages of ion cyclotron resonance: the highest recorded mass resolution of all mass spectrometers, powerful capabilities for ion chemistry and MS experiments. It produces well suited for use with pulse ionization methods such as MALDI, non-destructive ion detection and ion measurements. It produces stable mass calibration in superconducting magnet FTICR systems. Limitations of this analyzer: it produces limited dynamic range. Strict low pressure requirements mandate an external source for most analytical applications, subject to space charge effect and ion molecule reactions. Application of this analyzer is it have ion chemistry, produce high resolution electrospray experiments for high mass analytes, the laser dispersion for materials and surface characterization. Second part of is mass detector. Mass detector detects a current signal generated from the incident ions. Different mass detectors are used to detect ions depending on the type of mass spectrometer. The most common use of detectors in mass spectroscopy is electron multiplier, Faraday cup, photomultiplier conversion diode, high energy diode detector, array detector, charge detector. First one is multi-channel plate. In multi-channel plate detector, the detector which measures one m by e value at a time called single channel detector. Multi-channel plate detectors are used for the detection of multiple ions beam with difference m by e value. It have high resolution magnetic sector instruments. Use multi-channel detectors. It also called as multi-collectors or multi-collector detector. Second one is electron multiplier. In this electron multiplier detector, the most common detector in which one is the most common spectrometer for ions? Similar to PMT, very sensitive and has fast response. Third one is Faraday cup. A metal or carbon cup serves to capture ions and store the charge. It has the cup shape, cup shape and decrease loss of electron. It have a less expensive detector for ions as compared to other detectors. It produces long response time. Fourth one is array detector. Array detector is used TOF mass spectroscopy. It employs a focal plane camera consisting of an array of 31st Faraday cup. It has the 15 M/E value can be measured simultaneously. It exhibits improved precision compared with single channel detector. Last part of its the use of computers in mass spectroscopy. In mass spectroscopy, the computer is used to calculate values for metastable ions or to calculate the chemical formula associated with specific molecular weights. Computers were infrared interface with mass spectrometers to directly collect mass spectra, which means that the computers are a very the computers are used in mass spectroscopy. Thank you.